So let's start errors and measurements now. Okay, so errors and experiment or what else? So different types. So whenever you conduct any kind of say experiment, or whenever you conduct any kind of any kind of experiment, or you're measuring any kind of value. Okay, so for example, I'm measuring the weight of some object. So let's go for the basic thing. Okay, so most basic example is I take an object and I place it on top of the weighing scale. So when you place an object on top of the weighing scale, do you think that you always get an accurate reading? No, right? So you don't get always an exact measurement. So if I weigh, for example, one apple, I'm weighing just one apple, for example, I weigh one apple. The weight of one apple is say 50 grams. So do you think that the value, the 50 grams value that you're getting is actually an accurate value? No, right? So it's not an accurate value. Why? Because the weighing scale shows some deflection. So generally, most of the times if you see, even without placing the apple, even if you don't place the apple on top of the weighing scale, it still shows some reading. So sometimes the scale will have some reading in the beginning before placing the apple. So it may show some 2 grams, for example, the reading. So that is our error. So the weighing scale shows some error from the accurate reading. So your apple has to be 18 gram, but actually it shows 20 gram because 2 grams was present on the scale from the beginning, right? So as our equipments get older, so as time goes on, as you use your any kind of equipment, measuring equipment more and more often, generally what happens, the weighing scale shows some error. So that is called error. Error is inaccuracy in measurement. So when you're measuring something, it doesn't show you an accurate reading. Accurate means what is the correct reading that it has, what is the correct reading. From that there will be a deviation. So if this is the correct reading, for example, it may show you some number below that or some number above that. It can show you some number below that or some number above that. So that is called the inaccuracy, or that is the reason for error. Okay, so sometimes maybe humans also do errors. So there are different types of errors. Basically this is error in measuring equipment, but there are different types. I will not be telling you about different types of errors because that's not required. We need to be able to solve the questions. So that's more important than learning all these stuff. But still I'm giving you an overview. Okay, so now you know that. So sometimes what happens, we may not see the scale properly. We cannot see the scale. Okay, so you have seen when you're measuring, sometimes in analog meters and all, if there is analog and digital, you know, two types, right? So what happens, the needle, if you see it from the side, you will feel that the reading is more, and if you look from the side, you will feel that the reading is less because the scale is on the behind. If you look from the side, you may feel that the reading is more or less. So that 0.1 reading difference will be there from the angle from which you're seeing. If you look from the side, you will feel that the reading is more. If you look from the side, this is because of parallax effect, because we have two eyes, right? We watch objects in 3D. So when you're seeing from the side, it's called parallax. Okay, so all that you will be learning. So parallax effect is from the two eyes when you see. So when you look at one object, both the eyes are responsible for that. So when you see the objects in 3D, chances are there that you can see the needle this side or that side. If you observe from this side, the needle will look this side, and if you observe from this side, so that's what happens. Yes, that is another reason for error. So what is error now? So error is represented by delta x basically. Okay, so when you basically whenever you are representing, so you can see error is represented by delta x. What's delta x? Delta x is nothing but error. Okay, error in x. So if you are measuring a quantity x, for example, so weight, for example, if you are measuring quantity weight, so weight is x, so 5 grams is the weight. So plus, so I gave you example of apple, right? So say some amount, some grams, so 20 grams is the weight of the apple. So if 2 grams is the error, it can be plus or minus 2 gram, because our equipment, we know that it's 2 gram more or less, but it's not exactly 20 gram. So that's error, delta x, that is represented by delta x. The 2 gram is delta x, and our reading is 20, that is x. Okay, so 20 plus or minus, we represent it by plus or minus 2 grams. So that's how we represent any value. So that plus or minus 2 grams is nothing but the error, and it's called delta x. Next, you also have something called as fractional error. Fractional error is nothing but the error, that is 2 gram, by the value you are measuring. So 2 by 20, it's called the fractional error. Okay, so that's called fractional error. Next, you have something called percentage error also. So 2 by 20 into 100 gives you percentage error. So fractional error into 100 gives you percentage error. So these are the three things you need to know. Delta x is error in x, and delta x by x is fractional error, and delta x by x into 100 gives you percentage error. Now if there is some quantity, if you are adding two quantities, what happens to their errors? That's what you need to know. So if for example y is there, any quantity, result. So if you add two apples, what is the weight of two apples, for example? So one apple weight is say 20 gram and another apple is say 30 gram. So what happens to the resultant? You will get the actual reading, right? Weight of two apples. What is the weight of two apples? Is it 50 gram? Yes, okay, fine. Y is 50 gram. But what happens to error? You need to write even the error, right? So error becomes delta x1 plus x2. So error will be 5 gram. If the error in first measurement was 2 and in second measurement was 3, so total error is 5. So when you add two quantities, errors get added. And another thing you need to know is, when you subtract two quantities, still the errors get added. So for example, if I subtract the weight of one apple and another apple, I'm trying to find out the difference between the weight of their apples. So 30 gram minus 20 gram gives 10 gram, right? So 10 gram is the difference between the two apples weight. But what happens to error? 10 plus or minus 5 only you need to write, because the error is still 5. You need to always add the errors. So errors are always added. Okay, so hope you understood. You need to remember that errors will always get added. Even if you subtract two quantities, even if you add two quantities, error in one was 3, error in another is 2, so total error is 5. So if you are subtracting the two quantities, weight of one apple minus the weight of other apple, that is 30 gram minus 20 gram, 10 gram, right? So 10 gram is the difference, plus or minus 5. So still the error will be 5. Error will always get added. Next, what happens if you multiply the quantities or divide the quantities? So say for example here I have taken multiplication of two quantities z, x to the power a and y to the power b. Right, x to the power a and y to the power b. So if you are multiplying or dividing means to the power will become minus 1. Okay, so if I'm dividing x and y, what will it be? X into y to the power minus 1, right? So that's what. So you can take this equation as multiplication or division, anything. Based on that, powers will get different. Okay, so what you get here? So here you get delta x by x. Here you need to include the fractional error. Okay, so fractional error of the total quantity for the quantity which you multiplied. So it's z. Okay, so fractional error of z will be mod of a. So if any power has minus 1, you will take it 1. If it has minus 2, you will take it 2 and then multiply it by the fractional error of each term. So that's how you get the total error in case of multiplication or division. In such situation, mod, you will take only the mod of the quantity. You will not take minus 1, you will not take minus 2, you will take mod of that. Okay, for multiplication and division. Hope it's clear, right? So next, what we will be learning for multiplication and division. So next you have something called as absolute error. So what's absolute error? Absolute means, how do you find error? So basically now, until now, whatever I thought it was errors. What is error? You know the errors. Using that, how do you do calculations? Final calculation. Add, what happens to errors when you add two quantities? Subtract, when you subtract two quantities, what happens to error? All that we found out. But now, how do you find error? So to find absolute error, there's something called absolute error. You take mean of all the values. So total whatever values are there, you take mean of that and subtract individual error. Subtract. So you take all the values basically. So if I'm taking say 10 reading. Okay, 10 values I have, different values. So basically I'm trying to find height of all the students in the class. Okay, what's the error in that case? So I take height of all the students, then I subtract individuals, then I find mean of all the values. Okay, I will find the mean means average of all the students' height. Then I subtract individual students' height from each student's height. Got it? So say one student height is 100 centimeter, but average was found to be, say, average was found to be 80 centimeter. So what's delta a n here? What's absolute error? 20, like that. Okay, so that's called absolute error. And how do you find final or mean absolute error? All the errors we will add now. Okay, so basically you got different errors, right? Error in first quantity, second quantity, third quantity after taking average, right? So all the errors we will add, then divided by number of the terms that you were taking. So delta a1 plus delta a2 plus delta a3, like that, and so on, and divided by n. Okay, so that's called final or absolute error. So you will get a final error, absolute error. That's called final or mean absolute error. Final or mean absolute error. Next, what is maximum permissible error? So this is very important. What's the maximum error that's allowed or maximum permissible error? So that is the least count of the measuring device. So that is the least count of maximum permissible error is nothing but the least count of your measuring device. So for example, every device can measure some least value, right? So that is the maximum error that's allowed. So basically, see, for example, your scale can take lowest measurement as 1 centimeter. If the error is more than 1 centimeter, then that's stupidity, right? No use of such a measuring equipment. So always, whatever is the lowest value, if the error is more than that, it's not allowed. So lowest value, what your measuring device can, say for example, you have a weighing scale which can weigh up to 1 gram. So lowest weight it can measure is 1 gram. But the error itself is 2 gram. Chances are your weighing scale can have error only up to 2 gram. Will you use such an equipment? No. Right? So maximum permissible error is the least count. Least count means whatever is the lowest value your measuring scale can measure. What if the least count is not given? If least count is not given, you need to take the place value. It's the place value of last digit. So for example, I give you a reading 2.22 gram. Okay, 2.22 gram is what I gave you. So what's the least count here? 0.01 gram. That's the least count, because if your scale is showing you 2.22 gram, it means it can measure 0.01 gram. It can measure because it measured that 2.22 right at the end. So it can measure up to that level. So that 0.01 is the least count in such a situation. So whatever value is there, you need to make all the numbers 0 and you need to keep the last number as 1, last digit as 1. That will be your least count in such a situation. Got it? So next, what do we have? So if you are understanding, please comment down below. that you are getting it. Okay, so and next, what is screw gauge? We'll be learning about different types of equipments. So screw gauge and vernier caliper, these are the two things we use to measure the dimensions of any object in our laboratories and all. To measure small things and all, we use screw gauge and vernier caliper. So screw gauge, least count for a screw gauge is how much? What is the lowest a screw gauge can measure? It is nothing but pitch by number of divisions on circular scale. So in a screw gauge, you have circular scale and a linear scale. That circular scale moves on top. If this is the linear scale, on top of that there is a circular scale. If you rotate the circular scale, it moves on top of the linear scale. Circular scale also has divisions and linear scale also has divisions. So number of divisions on circular scale divided by pitch. So when you rotate it one time completely, how much it moves on the linear scale, that is called the pitch. So on rotating it one time, if I rotate it once, complete rotation, how much it moves on the main scale, main scale, right? So that is called the pitch. So one linear distance traveled in one full rotation. So I will rotate it one time completely. That is called. So pitch divided by number of divisions on circular scale is called the least count. And how do you get the reading? Main scale reading. So the main scale shows you some value plus circular scale also shows you some value, right? Circular scale, I told you, even that has numbers. Circular scale into least count. Whatever is the least count, you found out the least count using this formula, right? So that is called the reading. That will be our final reading. So this is how the screw gauge looks. I'm showing you. So screw gauge looks like that. You have a circular scale or how that. Got it? So next we have vernier caliper. Vernier caliper is nothing but, again, it's a device which is used to take measurements and all. So in case of vernier caliper, what you do? In case of vernier caliper, has two scales, vernier scale and main scale. So number of vernier scale divisions will be equal to some number of main scale division, right? Some vernier scale divisions will be equal to some main scale division. So you have vernier scale, you have a vernier scale and you have a main scale on the vernier caliper. So how many vernier scale division is equal to how many main scale division? You can see, right? This many vernier scale division is equal to this. So say for example 10 vernier scale division is equal to 5 vernier main scale division, like that. So you need to write that first. So how many vernier scale division is equal to how many main scale division? From there you can find out one vernier scale division is equal to how many main scale division, right? So one vernier scale division will be equal to how much? Number of main scale division divided by number of vernier scale, what you got, NV, into 1 MSD. What is 1 main scale division? So you get that. And then when you subtract both, that is the least count. 1 main scale division minus 1 vernier scale division is the least count in case of vernier caliper. And what's the final reading? So here again the final reading is main scale reading plus vernier scale division, vernier scale reading into the least count, whatever is the least count. Okay, so this is almost similar to the previous one. Even in screw gauge you had same thing, main scale reading plus circular scale reading. Here it's vernier scale reading into least count. It's the same thing. And you can substitute the value of vernier scale division, right? You know the vernier scale reading, right, from the previous question. We derived it. So vernier scale reading, if you substitute and if you take common, you will get 1 minus NM by NV into main scale division. And that is the reading. And what is actual reading? So this is for both screw gauge and for the vernier scale. Actual reading is nothing but observed reading. So this is the observed reading. Whatever I have written the formula for reading, that is the observed reading. If you minus that with zero error, there will be some zero error, right? Without placing any object. So I gave you example of wing scale. Like that only in vernier caliper also, without placing any object, when you attach both the tips, still it shows some reading. That is called zero error. You need to subtract the zero error from actual reading. If zero error is in positive, then you need to subtract it. If zero error comes in minus, then it will get added, right?